So a lot of times in real life, we want to find the area of a truncated cone. That's a cone where the tip has been sliced off. So it's not that difficult as you might first think, thinking that, oh, it's this weird shape. But all we really need to do is find the area of the original cone before it had its cone cut off, and subtract the area of the part that's cut off, which is also a cone. We know how to find the surface area of a cone. So we could easily find the area of those two cones and subtract. Don't forget, we need to find slant height. So slant height, we use Pythagorean theorem. So if we have the height and radius of the cone, the slant height is the hypotenuse, and so we can do radius squared plus height squared and take the square root of that to get our slant heights. Note that if we are trying to determine a radius and height for these two pieces, that they would be proportional. The ratio of the radius to height on the big cone would be equal to the ratio of the radius and height on the cut off cone. So that's important if you're picking the height of what you're going to cut off. That determines what this radius will be. And you can plug those values in to determine them. For example, our radius and height of our big cone are 5 and 10. So that's a 1-to-2 ratio. We determined we were going to cut the height of 3. So actually our radius of the cutoff piece should be 1.5. So this should be 1.5 centimeters to be realistic. The lateral surface area, and that's often cones are open because we're pouring stuff into it. So that circle on the top is open. So we usually want lateral surface area. We do the lateral surface area of the total cone minus lateral surface area of the cut off part to get that truncated cone surface area. Volume would be the same. Volume of the total cone minus volume of the cut off cone would get you the volume that the